Thank you so much for joining MEPS Connect, and don't forget to subscribe. Now let's look at the first question here. So first question here is an optimization question, right? Which says that we have two non-negative, that's the word there, real values, x and y, that add up to 10. So let's add that one to 10. So x plus y should be equal to 10. So from here, I can make y the subject and have 10 minus x. Now we need to, or we want to minimize this function here. So we are going to have 4x squared plus y squared. We need to minimize this. Now, because we have y to be equal to 10 minus x, we can do the substitution here to have 4x squared plus 10 minus x all squared. And then now that the function is in terms of x, we can say that, okay, we have a of x, which is equal to 4x squared plus 10 minus x all squared. So this is the function that we want to optimize, right? So that's the first question. But the question is asking us to find the domain. Now, the function here is kind of like, we don't have any rational function divided by anything. So here, what we can do is we can say that let our x be greater than or equal to 0 and y to be greater than or equal to 0. Now, y here is equal to 10 minus x. So we can replace this y by 10 minus x and have 10 minus x greater than or equal to 0. Add x on both sides and we are going to have 10 is greater than or equal to x. This is the same as x being less than or equal to 10. So now we have x greater than or equal to 0 and x which cannot exceed 10. So it means that the domain here is going to be 0 and 10. So this is how we can find our domain, right? So now we have the domain and we have the function that we want to optimize. So we are done with A. We can move to question B. Now let's look at question B. So question B is we need to use calculus to find x and y so that we can minimize this function. Now this function here is what we used here, and because we replace it y by 10 minus x, we had this. So basically we are going to use this function here at B. So I have ax, which is equal to 4x squared plus 10 minus x squared. So now that we want to find x and y, then we need to find the critical point by taking the first derivative of this function. So a prime of x will be equal to, now let's use the power rule here, and we have 8x plus. Now this one we need to use the power rule and then the chain rule. So here the power rule first, we need to drop 2, 10 minus x, subtract 1 from the 2 and you get 1. Then you need to multiply this one by now taking the derivative of what is inside the parenthesis, and we are going to have minus 1. Let's simplify this. We have 8x and then minus 2x, 10 minus x. Now this is the same as 8x minus 20 plus 2x, and this is 10x minus 20. So now that we want to find x, remember, if you want to find critical point, we need to make sure that our first derivative is equal to 0. So it means that 10x minus 20 should be equal to 0. And when I add 20 on both sides, I have 10x is equal to 20 and my x should be equal to 2. So now I have my x, I need y. But from A, we have y to be equal to 10 minus x. So meaning that we can write this one as y equals to 10 minus x. Now x is 2, so my y will be 8. So now we have x is equal to 2 and y is equal to 8. So that's basically what we just need from B. Now let's look at C. We want to verify this value if that's the minimum, right? We have 3 ways of doing this. We can use the table, we can use the second derivative test, we can even use the sign chart to do that. So let's do all of them together here. Now I can use the table here and have my x and have my a of x because that's what I was using. Now, the values that are going to be here should be the domain and then the critical point. So I have my domain here, which is 0, 10. Anything in between the endpoint, which is the domain, should be a critical point. And we had it to be 2. Now, somebody will ask, what about 8? Now, remember, this is x, so we need all x value, not y values. So now we need f of a of 0, and we need a of 2, and we need a of 10. Now, what is a of x? Remember, a of x was this here. So let me just write it here, 4x squared plus 10 minus x squared. So plug in 0, what do we get? 0 here will be 4 times 0 plus, when I plug in 0 here, this is going to be just 10 squared, and this is equal to 100. Plug in 2, this is going to be 4 times 4, because 2 squared is 4, plus 8 squared, and 16 plus 64, which is equal to 80. And then plug in 10, this is going to be 4 times 100 plus 0 squared, which is equal to 400. So we can see that the minimum is basically here. So here we can conclude that the minimum occurs at x is equal to 4, right? So minimum occurs at x is equal to 2, right? So indeed, we've verified that. Now we can also use a sign chart for the first derivative. So let's use a sign chart here. If I put 2 here, now remember, anytime you are using a sign chart, this we need to use the first derivative. So I pick any value here, and I pick any value here after 2 and before 2. Now what is, okay, this is a, so let's use a here. So what is a prime of 1? Let me plug in 1 here. When I plug in 1 here, this will be 10 minus 20, and this is going to be minus, and this will be decreasing. Now when I plug in 3 here, I'm going to have 30 minus 20, and this is going to be positive. This is increasing. So you can see that this indeed tells that this is going to be a minimum, right? A minimum here. Look at minimum, as we can see from there. Let's use the second derivative test too. So for the second derivative test, we need to make sure that we find a prime prime of x. And here we are going to have, when I take the derivative of this, I'm going to have this one to be 10. And remember, anytime we have the second derivative to be positive, we have what? Concave up. So here we have concave up. So now we are going to conclude that indeed the minimum occurs at s is equal to 2. Now what you need to know from here is either you choose this, or you choose the first sign chart, or you use the second derivative test. So you don't need to do all the 3. You can choose one of this to work with. But one advice that I will give here is, when you have the domain to be finite, it's good for you to use the table here, right? To just go straight. But when you have the domain to be, let's say, minus infinity to positive infinity, then it's good for you to use the sign chart. Either this or the second derivative test is the best way to verify. Now let's look at question 2. Now question 2, we have f of x, f prime, and then f prime prime. Now we want to use a sign chart to find the intervals where the function is increasing and decreasing. So now, before we use a sign chart, we need the first derivative, which is given to us. So all we need to do here is we just need to find for the critical point. So let's do that. Now let's find the critical point. So critical point here is when f prime of x is equal to 0. So now let's look at this function here. What are the values of x that makes this function 0? So I can see that when x is 1, this will go to 0, and when x is 4, this one too will go to 0. So it means that I'm going to have x is equal to 1 and x is equal to 4. That will be my critical point. So now that we have the critical point, let's use a sign chart. So this is my sign chart. Let me put my 1 here. Let me put my 4 here. So since we are looking for increasing and decreasing, we need to use f prime. So f prime, anything before 1, I can pick 0. In between 1 and 4, I can pick 2 or 3. And after 4, I can pick 5. So now plug in 0 inside this, and what do we get? So let's test the signs. When I'm plugging in 0 here, I'm going to have 4 times. When I plug in 0 here, I'm going to have negative. And when I plug in 0 here, because this is squared, I'm going to have positive. So this one is going to be positive. So this is going to be negative, positive, which is negative. So this is negative and this is decreasing, right? Because of the square. Plug in 2. When I plug in 2 here, I'm going to have positive. When I plug in 2 here, it's going to be also positive because of the squared. So this is going to be 4, positive, positive, which is positive. So this will be increasing like this. Now let me plug in 5 here. Now when I plug in 5 here, 5 here will be positive, 5 here too will be positive. So this is going to be positive, positive, which is also positive again. So this is going to be positive and this will be increasing this way. So since we need the increasing interval, so increasing interval is going to be from 1 to 4 and from 4 to positive infinity, because this is where we have the function increasing. You cannot add them together. Let's say from 1 to positive infinity, you need to divide them into 2. And then the decreasing interval is going to be from negative infinity to 1. Yes. So that will be the decreasing interval from there. Now let's look at question 2. Use your answer in part A to determine the value of x where f has a local maximum and minimum. Okay, so now we need to just use this sign chart to check for local maximum and minimum. So now we can see that we have something like this, right? Decreasing, increasing. So local minimum happens there. So we have local minimum, which is at x is equal to 1. But here the sign is not changed. We have positive, positive. So here we don't have local max. So no local maximum. So that is basically what is happening there. Now let's look at the C for question 2. Use sign chart to find the interval where the function is concave up and down. So for concave up and down, we need to use the second derivative test, right? We need to use the second derivative test. So first, for us to draw our sign chart, we need values of x that will make sure that the second derivative test is 0. So here when x is 4, this will be 0, and when x is 2, this one too will be 0. So it means that our x value will be x is equal to 2 and 4. Yes. So now we can design, or we can draw our sign chart here and put my 2 here, put my 4 here. Now here we are using f prime prime because we are talking about concave up and down. So I can pick 1, or let me say, yeah, I can pick 1. 1 is a critical value, so we shouldn't use that. Let's use something like 0, right? Good. And let me pick something like 3 here, and let me pick something like 5 here. Okay. So now let's try and put them in and see what is going to happen. Let me write f prime prime here so that we can see it very well. This is 4x minus 4, x minus 2. X minus 4, x minus 2. So now let's plug in 0 here. So when I plug in 0, I'm going to have 4. When I plug in 0 here, this is going to be minus because 0 minus 4 is minus. And when I plug in 0 there, I'm going to also get minus again. So minus minus will be positive. So this is positive. And remember, we are using concave up and concave down. So if it is positive, we move to concave up. Now let's plug in 3. When I plug in 3, the first one here will be negative, right? So it will be negative. And then when you plug in negative, when you plug in 3 here, you are going to get positive. So positive. So negative positive is negative, and this is going to be concave down. And then the last one is when you plug in 5. So it's going to be positive, and then the other one too will be positive. So this is positive, and this is up here. So the interval for concave up and down is going to be this. Let me shift this one small. So concave up is going to be from negative infinity to 2, and from 4 to positive infinity. So this is where the concave up happens, right? And then concave down is going to be between 2 and 4. So we just have concave down here. Then the question is also saying that we should use what we did in C to determine the point of inflection. Now remember, point of inflection is when the sign is changing, right? So if the sign is not changing, then we cannot have point of inflection. So good for us, 2 and 4 is making this one 0, the second derivative 0, and also the sign is changing from positive to negative and negative to positive. So the point of inflection here is x is equal to 2 and x is equal to 4, because the sign is changing. Good. So that will be our point of inflection here. Now let's move to question 3. Now question 3, we want to find the derivative of the following functions. So first we have the natural log function here. Now have it in mind that anytime I want to take derivative of the natural log, I'm going to have d over dx. If it is the length of u, then this is equal to 1 divided by u times u prime. So that is the general rule that we need to learn. So here, when you compare this here to this, you will see that our u is equal to 9 minus x squared. So looking at what the out product here, we need u prime. So we need u prime, and this is minus 2x. So what is f prime here? F prime is equal to 1 divided by u, which is this, 9 minus x squared, times u prime, which is this. So the way of differentiating a natural log function goes like this: 1 divided by what is inside the parenthesis times the derivative of what is inside the parenthesis. But if you cannot memorize this or have this in mind, then just remember this, and then always pick your u and u prime and just go through this. So it means that our answer is going to be minus 2x divided by 9 minus x squared. So that's what we are going to get from here. Now let's look at this one too. Now anytime we have the inverse function, sine is like this. Now don't forget, sine inverse is the same as the arc sine. So this, I'm going to make it in terms of u. So in terms of u, this is equal to 1 divided by square root of 1 minus u squared times u prime. Good. So that now, because of this, we can do the change rule very well here. Now compare this to this. The one here, this is the sine inverse, this is the sine inverse. You can see that u is equal to x squared. So my u is equal to x squared. I need u prime. So what will be u prime? U prime will be equal to 2x. So think about f prime here. F prime of x, which is the same as differentiating this, will be equal to 1 divided by square root of, now don't forget, 1 minus u squared. But what is u? U is x squared. So this is going to be 1 minus x squared squared times u prime, which is 2x, times 2x. Right, so that's basically what we just need to know from here. And this is the same as the final answer here, which is 2x divided by square root of, so if I want to multiply the 2 to 2, I'll have 1 minus x to the power 4. So that's what I'm going to have from here. So you just need to remember this. And then now pick your u, find your u prime, and just do substitution, and then you are done here. So you can remember, when I finish, I'll make sure that I'll give you all the derivative of the trig function so that you can learn it before your exams. Now let's look at the linear approximation here. So now remember we said linear approximation, we need to have the function to be this, which is equal to f of a plus f prime of a x minus a, right? This is how it's supposed to be. And this is similar to the equation of the tangent line, right? Which is y minus y1, which is equal to mx minus a minus x1, right? It's the same thing. And if I make y the subject, I have y1 plus mx minus x1. So when you compare this, this is equal to this, and then the slope is the f prime of a, and then x1 is this one here. So any of them that you want to use is a great way to go through the process. But let me use this. Now, anytime you are using this, don't forget that the x given here is not actually the x here. The x given here is the a, right? So this here is the same as a, not the x. So now it means that my linear approximation will be equal to f of 1 plus f prime of 1 x minus 1. Now, fortunate for us, we don't need to do any work because f of 1 is given, and then f prime of 1 is also given. So it means that our linear approximation will be equal to 2 plus 3x minus 1. And if you want to expand this, then this is the same as 2 plus 3x minus 3, and this is 3x minus 1. So this is what you are going to get if you want to expand. If you don't want to expand, you can just leave it this way here without concentrating on this one in the blue. So now the B is asking us to approximate A, this. So let's go. Now f of 1.01 is the same as, we need to approximate it. So we are going to use the linear approximation, which is this. And this is going to be linear approximation of 1.01, and we can plug it in here. So let me just use the one which is blue here. So this is going to be 2 plus 3, 1.01 minus 1. And this is 2 plus 3, and this is 0.01, 0.01, sorry. And this is the same as 2 plus 0.03, and this is 2.03 as the linear approximation here. Yes, so this is what we are going to get for question 4. Let's look at question 5, which we are going to use the L'Hopital's rule. Now, for L'Hopital's rule, we need to test it first. So now let's try and plug in 0 and see what's going to happen. So when I plug in 0 here, what is sine 0? Sine 0 is 0. And when I plug in 0 here to 0, so it means that I can use the L'Hopital's rule. So I can say that this is equal to L'Hopital's rule on top, and then L'Hopital's rule is telling us that if this one is true, then we just differentiate the top and the down. So this is the same as limit x is approaching 0. And you can see that whilst I'm applying the L'Hopital rule, I'm using the limit, or I'm writing the limit again. So don't forget to write the limit when you are doing this. And when I differentiate sine, what am I going to get? So we need to use the change rule here. So differentiate sine and get cos 3x times, now change rule, we need to differentiate what is inside, and this is going to give us 3. So it means that this is going to give us 3 cos 3x, because when I multiply this, this will be this. Divided by, when I differentiate x, I get 1. So this is the same as limit x is approaching 0 of 3 cos of 3x. So now let's try and plug in 0 and see what is cos of 0, because 3 times 0 is 0. Cos of 0 is 1. So now it means that we are setting x is equal to 0. So this is now I'm not going to write the limit because now we are going to do substitution there. And this is going to be 3 times 1, and this is going to give us 3 because cos of 0 is 1. Very simple from there. Now let's look at B. So B is the one that, now that we have this on top here, then we need to make sure that this comes down. So if that's the case, then we need to make sure that first this is equal to L. Then we take the natural log on both sides. So I'm going to have limit x is approaching 0 from the positive. When I take the natural log on both sides, I'm going to have natural log 3x plus 1, 2 divided by x, which is equal to the natural log of L, right? Now, this natural log will help us to bring this down. So now this will be limit x is approaching 0 from the positive, and then I have 2x ln of 3x plus 1, which is equal to ln of L. Now let's see something here. This is already divided. So now we can write this one as limit x is approaching 0. And this is the same as 3x plus 1 divided by x. So this is true. So now that we were able to make sure that the function is here, and we have one function at the top, one function at the down, let's test it and see if we can apply the L'Hopital's rule. Now let's do it and see. Now plug in 0 here, and 3 times 0 will be 0, and it will be left with 1. And we know that natural log of 1 is 0, right? And 0 times 2 is going to be 0. So this, the top will be 0. And then when I plug in 0 here, still I'm going to get 0. So yes, we can apply the L'Hopital's rule. So now let's go ahead and apply the L'Hopital's rule. So now limit x is approaching 0 from the positive. Now let's differentiate this. What are we going to get? Now don't forget how to differentiate the length function. So if I want to differentiate the length function, d over dx of the natural log of u is equal to 1 divided by u times u prime. It's very important to remember that. So here, when I'm just doing for this, now I can see that my u is equal to 3x plus 1. So u prime will be equal to 3. So now I'm going to use this on the top here. So this is going to be, now don't forget there is 2 here, which is constant, so we are not touching it. So I have my 2 constant there. Then since I'm differentiating the length function, it's 1 over what is inside the parentheses, which is this here, 1 over u. So I'm going to have times 1 over 3x plus 1 times u prime, which is 3. And then I have this one to be 3. Divided by, when I differentiate x, I have 1. And this should be ln of L. We are almost there. Now, what is happening here is, now I can write this one as limit x is approaching 0 from the positive. I can multiply the 2 to the 3 and have 6 divided by 3x plus 1. Now this is divided by 1, so it just go away, and then I have this. Now one thing about L'Hopital's rule is, as soon as we are done taking the derivative, we need to do direct substitution again to see if we are getting a result, or we need to continue doing the differentiation. So let's do that. Plug in 0 here, and I think we have 1 here, so this is actually good. So now we can set x to 0 and have 6 divided by 3 times 0 is 0, so this is going to be 6 divided by 1, which is equal to this. And we are going to have 6 is equal to the natural log of L. And now finding our L, we are going to have e to the power 6, which is equal to L. So now our answer here is e to the power 6, because we said L is equal to this. So now our final result here should be e to the power 6. Nice. So it's just step by step and you are there. Now let's look at question 6. And question 6, we want to take the antiderivative, right? So let's do this. Okay, so we have f prime to be this. So this is how we need to think about antiderivative. Now think about antiderivative, that think about the function that you are differentiating to get this, right? For example, if I have f of x is equal to x squared, and then f prime will be equal to 2x. So if I want to move from this to this, if I want to move from 2x to x squared, now I'm thinking about what type of function, when I differentiate, I'll get 2x. As soon as I think about those things, it helps me to know the function that I differentiated to get 2x. So I ask myself, what function, when I differentiate, I get 2x? That is x squared. Then that is the results. So that is antiderivative here. So now let's see what is going to happen here. So we have f prime. So antiderivative is going to give us f of x, because when you take the integration there, it should be giving you f of x. Now ask yourself, how am I going to integrate this? Okay, fine. This one is very difficult to think about a function that you are going to integrate to have this, but I have this one for you. Anytime you are integrating an exponential function, this is how it goes. It is the exponential function divided by u prime. So you maintain the exponential function and you pick what is on the top and you differentiate it. So look at this. Compare this here to this. You can see that your u is 2x. So it means that here I have u to be equal to 2x. So I need u prime and it's going to be 2. So when I do substitution here, what is going to happen here is, now I'm going to have something like this, e to the power 2x divided by 2. So it's very simple. How do we do it? Just maintain the function and differentiate what is on the top and use it to divide. That's all. Maintain the function, divided by the derivative of what is on the top. Done. Now let's look at the next one here, secant squared. This, we don't have any strategy to do this. Think about the function that when you take the derivative, you get secant squared. And that one is going to help you to know what you are going to get this. So we know that when we take the derivative of tangent, that's when we have secant squared. So this is going to give us minus tangent of x plus. Now, let's look at this function here. Now, this one, we need to use the power rule. But before we use the power rule, how can you write this function so that we use the power rule? Now, remember that 3 divided by x squared is the same as 3 times 1 over x squared. So this one will help us to write this one as 3x to the power minus 2. Now we want to take the antiderivative. Now remember, antiderivative using the power rule, this is going to give us 3x minus 2 plus 1 divided by minus 2 plus 1. So this is what's going to happen here. And simplifying this is going to give us 3x to the power minus 1 divided by minus 1. And this is the same as minus 3x to the power minus 1. And if you want to simplify this, you can say that this is the same as minus 3 divided by x. So this is what we are going to use here. And this now becomes minus 3 divided by x. So this is what we are going to get here. So finally, now we can put our final results here and write e to the power 2x divided by 2 minus tangent of x minus 3 divided by x. But don't forget to add plus c, because if you don't add the plus c, 0.5 is gone. So if you want us to deduct 0.5, you can decide not to bring plus c. Okay, so now let's look at the question B. Okay, so question B, let's break the function again. Now we have 3 divided by x. So this is how you can be taking the derivative, the antiderivative, so that you don't get it wrong. Break them down and analyze them. Now 3 over x is the same as 3 times 1 over x. Now think about the function that you differentiated and you had 1 over x. That is the natural log of x. That's right. So it means that now when I integrate this, my f of x here, this is going to be, now here it's going to move to 3, and 1 over x is the natural log of x. So I'm going to have 3 the natural log of x. So that's what I'm going to get from here. Now let's move to the next one. So the next one is we have minus we have minus 2 divided by x squared plus 1. How can I write minus 2x squared plus 1? Now I can see some function here. So I'm going to write this one as minus 2 times 1 divided by x squared plus 1. Now, what function, when you differentiate, you get 1 over x squared plus 1. That is the arctangent or the tan inverse. So it means that this is going to give us minus 2 arctangent or tan inverse of x. So this is going to give us minus 2 arctangent or the tan inverse of x plus, now the last one to do here is, now we have 6 square root of x. What can we do here? Okay, this one too can be written as 6 x to the power 1 over 2, and we use the power rule for integration to do this. So this is going to be 6 1 over 2 plus 1 divided by 1 over 2 plus 1. Simplify this and we have 6. This is going to give us 3 over 2 divided by 3 over 2. And indeed, if I want to simplify this, you can leave it like that, right? And just come and write this one here. But if you want to simplify this, I can simplify this and have 2 over 3 times 6 and then x to the power 3 over 2. So that now this now becomes 4x to the power 2 over 3. If you want to simplify it. But if you don't want to simplify it, you can just leave it like that. Because the question says do not simplify. So since I simplified, I had this. Oh, this one's supposed to be 3 on 2. So I have 3 on 2 here. Plus my c. So my c is very, very important. So now let me write the final results here. Natural log of x minus 2 tan inverse of x plus 4x to the power 3 on 2 plus c. Good. So that's what we are going to get for B2. Now let's do our last question, last but one, because we have question 8. Now find a specific function that meets the following condition. So here, what we just want to do is very simple. We want to find the function that we differentiated to have this. That's all. So it means that we need to take the entire derivative. So this is going to be f of x. Let's use the power rule here. So this is going to be 3x 2 plus 1 divided by 2 plus 1 plus 4x. This is to the power 1. So this is going to be 1 plus 1 divided by 1 plus 1 plus. Now this is a constant, so we need to multiply it by the function that we are integrating with respect to, which is x, because the function is in terms of x. So 1 times x is x plus a constant. Let's simplify this. Let me just shift this guy here. Now, this is the same as 3x cubed divided by 3 plus 4x squared divided by 2 plus x plus c. And indeed, this is the same as x to the power 3 plus 2x squared plus x plus c. So now we need to find for c. So let me just write what we had here. We've gotten f of x is equal to x to the power 3 plus 2x squared plus x plus c. Now we have the initial condition here to help us to find the constant. So now let's go. Now compare this to this. We can see that x is equal to 1. So when x is equal to 1, we have 1 to the power 3 is 1. Now 1 to the power 2 is still 1 plus 1 plus c. Now what is f of 1? F of 1 is 2, which is given here. So we have 2, which is equal to 1 plus 2 plus 1 plus c. So this is 2 is equal to 4 plus c. And just guess what? What will be c? C should be minus 2. So we've gotten c to be minus 2. So in this box, now we are going to write our f of x again, but we are going to replace the c by minus 2 to get our original function. So this is going to be x to the power 3 plus 2x squared plus x minus 2. So this was the function that we differentiated to have this. So one way to check this is all the functions that you've done, you can decide to differentiate it and you're going to get this. Take the derivative of this and you get this. take derivative of this and you are going to get this. Take derivative of this and you're going to get this. And when you take derivative of minus 2, you get 0. And you see that, yes, indeed, that's a function that we differentiated to get this. And let's do the last question here before we move to spring 2025. Now, this is asking us to find all critical points. So for critical point, we need to make sure that f prime, or the first derivative, is equal to 0. So what is f prime? Let's use the, so one thing that you also need to learn here is, this exam is kind of like you are doing integration, you are doing differentiation, or you are doing antiderivative and derivative. So you need to make sure that you master your mind very well to make sure that when the question is saying that take the derivative, you are not using integration to do it. I've seen a lot of people being confused in exams, and where they're supposed to take derivative, they are taking antiderivative and vice versa. So now let's take derivative here. Using the power rule, we are going to have 6x squared plus 6x minus 12. So this is what you are going to get from here. Now, we can factor 6 out and have 6 out, x squared plus x minus 2. Now, how can you factor this? X squared plus x minus 2 is the same as x plus 2, x minus 1. So factorization is very important. Now let's try and check if it is true. X times x is x squared. X times this is minus x, and this time this is 2x, which is x, and 2 times this is this. So this is true. So we can see clear here that the critical point will be when x is equal to minus 2 and when s is equal to 1. Because when 2 is here, minus 2 is here, this will be 0. And when 1 is here, this 2 will be 0. So these are the critical points. Find the absolute maximum and minimum of the function. Okay. So this one, we just need a nice table. And then with this one, what you need to remember is make sure that you are using the original function and first state your endpoint from the domain. And the one which is going to be in between the endpoint should be a critical point, which is in between this. So now we ask ourselves question, we have minus 2 in between minus 1 and 2? No. So it means that this is out. Do we have 1 in between minus 1 and 2? Yes. So it means that we can bring the 1 here. So now we need f of minus 1, f of 1, and then f of 2. And what was f of x? Let me just write it here so that we can do it together. 2x cubed plus 3x squared minus 12x. So plug in minus 1, what do we get? When I plug in minus 1 here, minus 1 to the power 3 is minus 1. So this is minus 2. Minus 1 squared is 1. So this is 3. And then minus 1 times minus 12 is plus 12. So this should be giving us 1, 3, which is 13. Plug in 1. 1 to the power 3 is, so this one will be 2. This one will be 3. And this one will be minus 12. And this is going to give us minus 7. Plug in 2. 2 to the power 3 is 8. 8 times 2 is 16. Plus 2 squared is 4. 4 times 3 is 12. Minus 12 times 2 is 24. And then when I add this one, I'm going to have 28. So this should be 4. So where should be the maximum? Where should be the minimum? So the max should be here and the minimum should be here. So now let's state it correctly. So absolute maximum value equals well, let me see, absolute maximum x is equal to minus 1, or we can write it in the coordinate form and have it to be minus 1 and 13. And then absolute minimum, this is when x is equal to 1 And we can also write in the coordinate form, having something like this. Okay, so that is what we are going to get here. Okay, I think here I don't need to use the x, rather if the coordinate. So the absolute value, this is rather 13, and then the value should be here, and this one should be rather -7. Then if I want to write it in the coordinate form, that's when I have it this way. Yeah, so this is the end of the video, but I want to give you something, let me put some note here for you to enjoy. So first, since we are taking derivative, now this is derivative. Have it in mind that everything I'm writing here is derivative. So one, if I want to differentiate an exponential function, this is going to give me this times u prime. And if I want to differentiate the length function, this is going to give me 1 over u prime. Now, the trig inverse functions, I'm going to have, if I want to differentiate sine inverse of u, this is going to give me 1 divided by square root of 1 minus u squared times u prime. And it becomes bonus for cos, right? Because it's just the minus of this. So this is minus of the sine derivative, so minus u squared times u prime. Then we have for tangent, I'll just do 4. So tangent is 1 over 1 plus x squared. Now don't forget, since it's addition is commutative, so we can also use either x squared plus 1. So pay attention to here. This is the same as you writing u squared plus 1 times u squared, sorry, u prime. It's also the same thing. Then bonus for cotangent inverse of u is equal to just the minus of this, u squared plus 1 times u prime. Right, so this is what you are going to get. Now let me give you another tip before we close this section and we start the spring 2025. Now absolute max and minimum. Now don't forget, anytime you are doing this, you need the critical point, you need f prime. You use f prime to find the critical point. And then after the critical point, so how do you get the critical point? That's when f prime is equal to 0. Now check if critical point, so CP is the critical point, are in the domain. It's very, very important here, in the domain. If it is not in the domain, you cannot use it. Then as soon as you get the critical point in the domain, then it means that you are going to use this table here and then use it to do it. So that is absolute maximum and minimum. Now let's talk about local max and minimum. So for local max and minimum, you also need the f prime, you need the critical point, right? You need the critical point. That's when f prime of x is equal to 0. And the last thing that you need is the sign chart with f prime of x. So we use the sign chart, we use f prime of x, and then absolute, we use the table with f of x, the original function. And then last one, then we go to the next video, is concavity, concave up and down. Now concave up and down, we need f prime prime, right? And then we use f prime prime to, let me just call it inflection point. Even though for inflection point, we need to check when if the sign is changing. Even though the value can make f prime prime 0, but if the sign is not changing, then it's not inflection point. Then we also use the sign charts by here with f prime prime of x. So this is small information for you to also use. So see you in the next video.